Hi everyone, in today's lesson we're going to talk about solving basic log equations. We're going to need to convert the log expression to the exponential form first, and then we're going to either use the calculator, common bases, or raise both sides to the reciprocal power to solve what we're asking for. So let's look at example number 1. Example number 1 says, evaluate the following expressions. So we don't know what this expression is equal to. So we could write equals x. We don't know. Same thing with example 2. We can make this equals x. We're not sure. So we could now, step 1, change this logarithmic equation into an exponential equation. So we're going to put our pointer on the base, jump up to the exponent, and come back down to the answer. So we could say 27 to the x power equals 1 over 9. Now you can answer this right away if you already know the answer to the question. 27 to what power equals 1 over 9? If you know that, by all means put the answer. But if you don't, we're going to have to make a common base. So I know that anytime I have a fraction with a common base, I like to have this fraction and write it as a whole number. So this 9 is the same thing as saying 9 over 1. And I could write this with power of a negative 1. That's the same thing. Equals. Now how could I rewrite 27 with a base of 9? Can I? 9 to the first. It's 9. 9 squared, that's 81. So no good. So I'm thinking I got to drop it down to a power of 3. So how about I rewrite 27 as a base of 3? 3 to the third, and I want to raise that to the x power. And now I need to do the same to the other side. 9 is the same thing as saying 3 squared to the negative 1. 3 to the third to the x. Now I can distribute. 3 to the 3x equals 3 to the negative 2. Okay, now that I have the same bases, I can just cross the bases off and set the exponents equal to each other. So 3x equals negative 2. Divide both sides by 3. X equals negative 2/3. Okay, let's try example number 2. So first start by writing the log as an exponential. So 8 to the x power equals 32. 8 to the x equals 32. This would be great if I could say that 8 to some power actually equals 32 and I could be done, but it goes 8 to the first is 8. 8 to the second is 64, so that's no good. So we need to find a common base. I'm thinking we can use a base of 2. So 8 is the same thing as thinking 2 to the third. We want to raise that to the x power. 32 is the same thing as saying 2 to the fifth power. I can distribute the exponent. So I get 2 to the 3x equals 2 to the fifth. I can cross off the common bases, and I'm left with 3x equals 5. Divide both sides by 3. My final answer is 5 over 3. Okay, now let's move on to examples that actually have things that it's equal to. So same concept. The first thing that we always want to do is start by rewriting this log expression here as an exponential. So let's start at the base. 4 to the third power equals x. 4 to the third equals x. This one's easy now, right? All I got to do to equal x is put 4 to the third in the calculator. If you do that, you should get 64. So 64 is x. All right, let's try example number 2. It's a little different. So again, we're going to rewrite the log as an exponential. So let's start at the base. 6 squared equals all of this, all of that, equals x times x minus 5. Okay, this just looks like algebra. 6 squared on that left-hand side, I can make 36. X times x equals x squared. X times negative 5 is negative 5x. So now what I see here is that I probably need to get it equal to 0 because I have this x squared here. So I'm going to subtract 36 on both sides. And I'm going to get 0 equals x squared minus 5x minus 36. Now take a minute, see if you can factor this using AM. Pause the video, hit resume when you're finished. Okay, so you should be factoring this to x minus 9 and x plus 4. And when you solve, you should have two answers for x. X is equal to 9, or x is equal to negative 4. Now, here is the big part of this. You have to check the values that make the function undefined. And I don't know if you remember, but we talked that a function is undefined when this piece in here comes out to 0 or comes out negative. So what you want to do is plug these two numbers separately back into here and see if you get a negative number or if you get a 0. So let's write this down. Can't have negatives or 0. So I'm going to do it all over here. All right, I'm going to do the work on this side. So x minus 5. That's where I need to plug into. It's all of this stuff. So let's try 9. 9 times 9 minus 5. 9 times 4. 36. That's good. That's a positive number. We just, like I said over here, can't have a negative or 0. So now let's try the other root. Negative 4. Negative 4 minus 5. Well, negative 4 minus 5 is negative 9. Negative 9 times negative 4 equals positive 36. That works as well. Okay, let's try example number 3. So 27 to the 4/3 power must equal that. So 27 to the 4/3 equals 2x minus 1. All right, so this side looks weird, but all I have to do is put 27 to the 4/3 into my calculator, and I'll get what that equals. So take a minute, put that into the calculator, and see what you get. All right, you should be getting 81. So 81 equals 2x minus 1. Solve this equation for x. Add 1 to both sides. 82 equals 2x. Divide both sides by 2. X equals 41. Now to check, we got to check in here to see if we get 0 or negative. Okay, so we're going to plug in to 2x minus 1. For x, we're going to put in 41. So we're going to do 2 times 41 minus 1. You put that into your calculator and you should get 81. So that's a positive number, so I don't have to reject anything. That works nicely. Okay, why don't you pause the video and see if you could try number 4. Hit resume when you're done. Okay, so you should have done 5x minus 1 to the 1/3 power. That has to equal 4. Now some of you may be thinking, well, how do I get rid of this 1/3? You could say I can cube both sides. It would be the most appropriate, right? We would take this, raise it to the 3, or 3 over 1. These will cancel. I'll be left with 5x minus 1 equals 64. Add 1, you get 65. Divide both sides by 5. You should get x equals 13. Again, you want to check to see that in here is positive. Oh, well look, it's a number. It's 4. So everything will work. Awesome. All right, let's move on to the next page. Okay, let's look at example number 5. So this example says, if log base 4 of x equals 2.5 and log base y of 125 equals negative 3/2, find the value of x over y. So let's look at this equation first and see if we can get x by itself. So 4 to the 2.5 equals x. That doesn't sound too bad. Just put this into the calculator and see what you get. Pause the video until you've done so. Okay, you should be getting 32. All right, now let's try to find y. Y to the negative 3/2 equals 125. How do I solve this type of equation? How do I get rid of this negative 3/2? Well, you should be telling me raise both sides to the reciprocal, negative 2/3. Y equals, put this right-hand side into the calculator just the way you see it. You should be getting 0.04. Or you could change it to a fraction if you'd like, and that would be 1 over 25. So now we want to take x and divide it by y. Take this x, divide it by this y. So 32 divided by 0.04. I chose to use this decimal rather than this fraction because I didn't want to have to deal with in the calculator 32 divided by 1 over 25, but either way you should get the right answer. So take a minute, put this into the calculator, and see what you get. Alright, you should get 800, and that is your final answer. Okay, I saved the best question for last. Now this question is a little bit trickier, but I just want to make some of you aware that the first step that I'm going to do is take this log and turn it into an exponential. So let's do that. X plus 3 gets raised to the second power, and that equals x to the third plus x minus 2 all over x. That first step is testing your ability to change a log to an exponential. From here on is testing your ability to solve algebra. So I know it's confusing because we're combining the two things, but let's take this a little bit slower. I think I can simplify this. I know that x plus 3 squared means x plus 3 times x plus 3. So I'm going to double distribute that. X times x gives me x squared. X times 3, 3x, 3x, 9. So you should get x squared plus 6x plus 9. So this is what this part equals. So I'm going to just rewrite the whole thing over here. So x squared plus 6x plus 9 equals x to the third plus x minus 2 all over x. Now I can cross multiply if I put that over 1. So this times this equals this times this. So x to the third plus x minus 2 equals x times x squared plus 6x plus 9. We can distribute the x. We'd get x to the third plus 6x plus 9x equals x to the third plus x minus 2. Now you should be moving things from this side to this side or vice versa. Let's start with the highest exponent. So let's start with those x to the thirds. Let's subtract x to the third. What happens is they both cancel, which is nice. I didn't want to deal with the x to the thirds anyways. So let's bring everything else down. X minus 2 equals 6x squared, this should be a squared, 6x squared plus 9x. Now, this should be familiar to you. I see an x squared. These two terms belong on the right-hand side. So let's subtract x and add 2. Subtract x and add 2. So 0 equals 6x squared plus 8x plus 2. You now have two options at this point. You can take these three terms and see if you can factor it, t-chart, and solve, or you can choose to do the quadratic formula with this quadratic equation. I'm going to factor just because I think it's nice to practice that. So the first thing I notice is there's a GCF between the 6, the 8, and the 2. So I'm going to take out a GCF of 2, and I'm left with 3x squared plus 4x plus 1. Now I'm going to factor this inside using earmuff. So just as a refresher, 3x squared times 1 multiplies to 3x squared. What are the factors of 3x squared? Well, 1x and 3x comes to mind at first, and I think that's enough because 1x plus 3x adds to this 4x, because we needed to find the pair that added to this, and this is it. So we're going to bring down the 3x squared, bring down the 1, and fill the middle with the 1x and the 3x from over here. Now look at this. We've got 4 terms. We factor that by using grouping. GCF between these two, GCF between those two. So the GCF between these two should be x, and I'm left with 3x plus 1. What's the GCF between a 3 and a 1? There's really nothing but 1. So you take out a GCF of 1 and divide. You should get 3x plus 1. Now, since these two are the same, that can come out. and this term gets its own set of parentheses. And then don't forget to bring down this term up here. 2. All equals 0. And then do a t-chart. Can 2 equal 0? No, we reject that. 3x plus 1 equals 0. So quickly, I'm just going to write x equals negative 1/3. You'd have to do the math. I'm running out of room. X plus 1 equals 0 minus 1. X equals negative 1. So these two are your potential values for x. Now where do we need to check these two things into? These two answers must be checked into this part of the equation to see if it gives me 0 or a negative. So can't be 0 or negative. Now I know it's a lot of work to plug in those numbers into here, but you have a calculator that can put in fractions. So I'd like you to do that work and come in tomorrow and tell me which ones get rejected and which ones get to stay. All right, so that's your finishing that for homework. And then come in tomorrow and let us know. All right, see you tomorrow.